Welcome to section 3 of chapter 2. Earlier we've been working on the product and quotient rule, and so now day 3, let's pull in the trig functions and look at derivatives of all the 6 main trig functions, and also we're going to look at velocity and acceleration. First, I would like to start us out with discovering what the derivative of tangent is. So just a little bit of work here, and we can come up with that because you recall that tangent could be rewritten as sine x over cosine x. And now let's take the derivative of that. Well, that requires us to incorporate the quotient rule. And we know that. So derivative of the top will become cosine x times the bottom function. Minus, because quotient has a minus between them, derivative of the bottom, derivative of cosine turns into negative sine x for its derivative, and then I multiply by sine x all over bottom function squared, so cosine squared. Simplify on top, and I'm looking at cosine squared x minus, so that'll be a plus, sine squared x over cosine squared x. Simplify the top. Remember your Pythagorean identity. Cosine squared plus sine squared is the same thing as 1. I have this over the cosine squared of x. That's looking pretty concise, but there's one more thing we could do, and that is to rewrite this 1 over cosine squared into a cosecant squared. It's not cosecant, it's secant squared x. And we just discovered the derivative of tangent. Next, you'll have the table here that we're going to put our derivatives of the 6 trig functions in, just as a good place to come back and look until you have them memorized. Currently, I think you probably have this one memorized. The derivative of sine is cosine, and the derivative of cosine is negative sine of x. We just discovered that tangent turns out to be secant squared x. And if we did a little bit of work, I could take the derivative of cotan, much like I did tan, only I'd have, what, cosine x over sine x. The derivative of this, you would find, comes out to be negative cosecant squared x. Finally, on the last one here, our bottom row, the derivative of secant is secant x tan x. You could discover that if you went and converted secant to 1 over cosine and then used your quotient rule to come up with the derivative. Cosecant turns out to be negative cosecant x times the cotan of x. Make sure I got all those right. The reason I created the table the way I did is I wanted you to notice that anytime my trig function starts with the letter C, I happen to come in with a negative derivative. So that makes it, a way that you can determine when to use a negative and when to use the positive. Anytime the derivative or the trig function starts with the words of the letter C, cosine, cotan, cosecant, it's going to be a negative. All right, let's just practice a few of these. The derivative of 4 tan x minus 3 secant x. Well, that we can kind of look back at that table, and the derivative of tangent is positive, and it's a secant squared x. Minus 3 is our multiplier, so just write it down. And the derivative of secant is positive secant x tan x. The one little thing I could do on this, I suppose, is I could pull the secant out and I'd have 4 secant x minus 3 tan x. But that doesn't gain us a whole lot. So I would say either format is perfectly acceptable. Letter B, let's find the derivative of this. If I just said this to myself and read the function, it says y equals x cubed times cosecant x. Notice we said the word times. This requires the product rule. I have 2 functions multiplying by each other. So product rule on this. That'll give us y prime equals derivative of the first times the second added with derivative of the second. Now, the derivative of cosecant x is a negative cosecant x cotan x multiplied by the first function, which is x cubed. And let's see, what do they have in common? I see an x squared in common and a cosecant x, which I could pull out, and that would leave me with a 3, a minus sign, a cotan x, and we pulled an x squared, so it's going to leave us an x. I think I'll put it in the front there, and that would be a factored form of the previous line. I was just double checking my work, and it looks pretty good. Finally, letter C. This is going to require the quotient rule. And we're going to, use the same idea that we've been doing on all our quotient rules. It's just that we've got a trig function involved. So that's, just a little added extra on there. Get off the highlighter and I'll be okay. Oopsie. Sorry about that. All right, here we go. Y. It's still on that. Y prime equals, quotient rule goes, derivative of the top, and the derivative of cosecant is negative cosecant x cotan x. There's the first, the derivative of the top, multiplied by the bottom, so that'll be a 4x, minus derivative of the bottom multiplied by the top. Divided by the bottom squared. So I'm going to go ahead and square up my 4. That makes it 16. Square the x gives me 16x squared. All right, let's just simplify and push things, distribute things through. So 4x times 2x gives me 8x squared. 4x times this will be negative 4x cosecant x cotan x minus, take the minus 4 and distribute it through, minus 4x squared minus 4 cosecant x all over 16x squared. Simplify on top, y prime is equal to 8x minus 4x squared gives me 4x squared minus 4x cosecant x cotan x minus 4 cosecant x all over 16x squared. And if you happen to notice like I do, the top all have a 4 in common, so let's pull that 4 away from those. So I would have 4 x squared minus x cosecant x cotan x minus cosecant x all over the 16x squared. And then we can pull the 4 away and we'd have x squared minus x cosecant x cotan x minus cosecant x over 4x squared. And that is a nice simplified answer. We did this the other day. We did the higher order derivatives where we kept taking derivatives to move from first derivative to second derivative and so on. So I'm going to pass that by and let's work on this one. This should have a negative 27 tenths in there. So make that correction. On the moon, a ball is dropped from the height of 100 feet. Its height S in feet above the moon's surface is given by S equals negative 27 tenths t squared plus 100. Find the height, the velocity, and the acceleration of the ball when t is equal to 5 seconds. So the height is going to be this original function. So I could say S of t is negative 27 tenths t squared plus 100. If I wanted to know at time 5, I would simply take and plug 5 in. Okay, so I'm going to evaluate this at 5. S of 5. Well, we're going to plug in 5 then wherever we see t. Negative 27 tenths. 5 squared is 25 plus 100. Looks like some numbers we can do in our head. 5 goes into 25 5 times and into 10 twice. 5 times 27 would be 135. And then I need to divide that by 2. 135 and a half is 67.5. So I'm going to have negative 67.5 plus 100. Turns out to be minus 67.5. And if we do that real quick, I think it will be 22.5. Maybe 32. How about let's bump it to 32. There we go. 32.5. And that answer looks like it's going to be given in feet. Okay, velocity. Remembering velocity is the first derivative. So if I took my original position function and did a derivative on it, that's going to take me to velocity. Working off of this, the derivative of that would bring a 2 down. I'd have negative 2 times 27 divided by 10 t, and then plus 100, but the derivative of plus 100 will be plus 0. Simplify this. 2 goes into 10 5 times, so it looks like we have negative 27 fifths t. Evaluate s prime of t at 5. So let's replace t with the 5. And everywhere we see a 5, or t, we're going to replace it with 5. The 5's cancel, that's quite handy, and we get negative 27 feet per second. Now, something new. We're going to move to acceleration, and acceleration is the second derivative off of our position function. So s double prime of t will be, what I'm going to do is refer back to this level. I want to take the second derivative, so I'm going to take a derivative of the first derivative. And the derivative of that turns out to be 0. So acceleration is the second derivative, and on this one our acceleration is 0 feet per second squared. Even when evaluated at 5, because if I put 5 in here, it's still going to be 0. The problem 82 looks a little confusing at first, and then you kind of just got to take it step by step and do what they ask. Reading the directions, it says use the graphs of f, there's f, and of g. G is the lighter one, a little like light gray there. And then they define how q is created and how the p function is created. P is the product of f times g, and q is a quotient of f and g. Part A. Find p prime of 4. P prime of x, recall, was f of x times g of x. I'm sorry, regular p is f of x times g of x. We want to get to p prime, so p prime of x is going to be the product rule. Notice how they're held together with multiplication. Derivative of the first times the second, added with derivative of the second times the first. So there's kind of my game plan. I want to evaluate this thing when x is 4. So that's going to mean I need f prime of 4 and g of 4. Added with g prime of 4 times f of 4. Now refer to the graph to get our numbers. So first thing, the easy numbers to get are going to be the g and the f of 4. So g of 4, well, this is my x-axis, so here is 4 right there. I'm going to stop because that would be g of 4. G of 4 turns out to be a height of 1. Or we know it's the location 4, 1. G of 4 is 1. And, okay, so that was G of 4. I'm going to leave this other one open and then these two. F of 4. So from 4, I'm going to go up till I strike the F function, and the height that I landed at was 8. So F of 4 is equal to 8. F of 4 is equal to 8. Now we need F prime of 4, because I'm going back to this one here. F prime of 4 really refers to the slope at x being 4. Okay, so if I go up here on the f function and I look at what the tangent line to that point is, I notice that the tangent line is a horizontal line. That means its slope is equal to 0. So for f prime of 4, I put in 0. And now, let me clean this up just a bit. I got a lot going on here. G prime of 4 means what is the slope when I'm at x equals 4? That's this nice line there. That would be my tangent line at 4. Let's do a slope count. So up 1, right 2, 1, 2. That is a slope of 1/2. And now just putting it all together, I'd have 0 plus 4. It appears to me that this evaluates to 4. To save time, I'm not going to go through the quotient one, but it would be much the same. Find the second derivative. Let's do this 94 one, and then I'll get you the homework assignment. F prime of x. In order to get the second derivative, I've got to go through the first derivative. Derivative of x is 1. Derivative of the next term will bring down -2, multiply by 32, and then I'd have -2 minus 1. Simplify. And that is what we ended up with. F prime of x equals 1 minus 64x to the -3. Now let's take it into the second derivative. Derivative, and now we're working off of this one. Derivative of 1 is 0, and the derivative of the next term is going to be -64 times -3, and then x minus 3 subtract 1. This will turn out to be positive, and now let's just quickly take 64 times 3. Well, I'm thinking of this as 60, and that'd be 180 plus 112, or plus 12, so I'm at 192, which is positive because we had negative times negative, x to the -4th. It turns out I have 192 over x to the 4th, but in the denominator. Homework is looking like this. You can hit pause and write it down. Have a great day.